British rail pacer. Let's start in Britain, with a train so notorious it earned itself a nickname, the Nodding Donkey. The pacer was introduced as a cheap fix to keep smaller regional railway routes alive. Instead of building it like a proper train, engineers essentially borrowed parts and design philosophy from buses. That meant a lightweight body, stripped-down engineering, and a ride quality that felt less like rail travel and more like being shaken inside a shopping trolley. Quick pause before we keep going. If you're enjoying watching brilliant engineering ideas fall apart in slow motion, hit that subscribe button and drop a like on this video. It genuinely helps the channel grow, and it means more videos like this one heading your way. Now, back to the pacer. On rough or older sections of track, the pacer would bounce, rattle, and jolt its way down the line, much to the horror of anyone unlucky enough to be standing. It was cheap, it was practical on paper, and it kept small lines running for decades. But by the time it was finally retired, passengers weren't nostalgic. They were relieved. The Soviet nuclear missile train. Now let's go from uncomfortable to outright terrifying. The Soviet Union once turned an ordinary-looking passenger train into a mobile nuclear missile launcher. Known as the RT-23 Molodets, this system was designed to make Soviet nuclear weapons almost impossible to locate. From the outside, it looked like a standard train rolling through the countryside. Inside, it was hiding massive intercontinental ballistic missiles capable of carrying nuclear warheads. Instead of sitting in one fixed, easily targeted silo, these trains could roam across the entire Soviet rail network, disappearing into the ordinary flow of rail traffic. Sounds brilliant in theory, but turning a missile system into a train came with enormous problems. The trains were incredibly heavy, putting massive stress on regular railway infrastructure. Operating and maintaining them required specialized crews, dedicated facilities, and a logistics operation most militaries would rather not deal with. It was an astonishing feat of engineering, but also one giant expensive headache, and changing politics, sky-high costs, and arms control treaties eventually brought the whole program to an end. British Rail Class 139 back to Britain for something on the opposite end of the size scale. The Class 139 might be the smallest thing to ever legitimately call itself a train. Built specifically for the short Stourbridge branch line, it was designed to replace a much larger, more expensive-to-run conventional train. It succeeded at being lightweight and cheap to operate, but being tiny comes with obvious downsides. Passenger space was minimal, capacity was tiny, and the thing was only really capable of shuffling back and forth on its short little route. Its unusual boxy shape didn't help either. More than one person has compared it to a Fiat Multipla on rails rather than an actual train. It got the job done on its one specific branch line, but nobody was suggesting it should run anywhere that actually needed real passenger capacity. The APTE, Advanced Passenger Train, experimental. Britain wanted to build the future of high-speed rail, and the APTE was supposed to be the machine that got them there. The idea was clever. Instead of needing perfectly straight high-speed track, the train would tilt into corners, letting it take curves faster, while keeping passengers comfortable. It was genuinely ahead of its time, hitting speeds of over 150 miles per hour in testing, remarkable for the era. But then reality set in. The train ran on gas turbine engines, which were powerful but expensive and complicated to operate. The tilting mechanism itself was incredibly complex and needed years more development than anyone had budgeted for. Constant technical issues plagued the experimental design. Eventually, British Rail abandoned the gas turbine approach entirely, folding what they'd learned into later high-speed projects. The APTE itself never became a real passenger service, a brilliant proof of concept that turned out to be much harder to turn into something reliable than anyone expected. The Soviet turbojet train. If tilting trains and missile trains weren't strange enough, the Soviets also tried strapping literal jet engines to a train. Partly inspired by America's own jet-powered rail experiment, the M497 Black Beetle, Soviet engineers wanted to know if aircraft technology could make trains dramatically faster. So they took a standard railway vehicle and bolted on two turbojet engines. And astonishingly, it worked, sort of. The train hit genuinely impressive speeds during testing. But turbojet engines were built to push aircraft through open sky, not haul railcars down a track. The result was a machine that was ear-splittingly loud and burned through fuel at an absurd rate. The exhaust also caused real problems for nearby railway infrastructure. You can imagine what happens when you point jet engines directly down a train line. The project stayed firmly in the experimental stage. The UAC TurboTrain, the vacuum cleaner, America wanted its own slice of high-speed rail glory in the 1960s, and the UAC TurboTrain was meant to deliver it. Instead of a standard diesel engine, it used gas turbines borrowed from aircraft technology, giving it serious power and an actual world speed record for gas turbine trains. Then reality showed up, as it tends to do. Those turbines were extremely thirsty, and when fuel prices rose, operating costs shot up with them. The engines were also deafeningly loud, earning the train its unglamorous nickname, the vacuum cleaner. Despite all the futuristic tech, the ride itself wasn't remotely luxurious, with passengers regularly complaining about noise and discomfort. Reliability was another mess entirely, with mechanical problems piling up and the tilting system adding yet another layer of complexity to an already complicated machine. It did enter actual passenger service, credit where it's due, but it never became the high-speed revolution America had hoped for. Building something fast is one challenge. Keeping it comfortable, reliable, and affordable turned out to be an entirely different one. The Bud SPV 2000. Not every failure on this list came from a bad idea. Sometimes the idea was solid, but nearly everything around it went wrong. That's the story of the Bud SPV 2000. Built in the 1970s, it was meant to modernize American passenger rail with a lightweight diesel railcar that didn't need a separate locomotive at all. Lighter, more efficient, purpose-built for passenger service. On paper, it sounded like exactly what American rail needed. Then, the problems started. The diesel power system was complicated and painfully unreliable, leading to constant breakdowns and expensive repairs. Suspension issues, air conditioning failures, and other component problems piled on top. Only a small number were ever built, and their poor reliability meant they never became the modern rail solution Bud had promised. A great concept, undone by engineering and reliability that simply weren't there yet. The Baldwin Centipede, built in the 1940s. The Baldwin Centipede was meant to be a powerhouse diesel locomotive, and in raw numbers it was. Riding on 10 axles, hence the nickname, it used two separate engines to generate enormous amounts of power, making it one of the largest diesel locomotives of its era. But that complexity came at a cost. The engines suffered from constant reliability issues, maintenance was a nightmare, and keeping the thing running was expensive. Its sheer size made it far less flexible than simpler, smaller locomotives, and having two full engine setups meant twice the machinery that could, and did, go wrong. It eventually found a niche hauling heavy freight, but it never became the game-changing locomotive Baldwin had envisioned. All the muscle in the world doesn't help if the muscle keeps breaking down. The Beyer-Garratt Class 15A will end in southern Africa with a locomotive that looked like two trains welded together. Because in a sense, it was. Built for heavy freight duty, the Class 15A used the unusual Garratt design, with the boiler suspended between two completely separate engine units. This let it carry huge amounts of fuel and water while spreading its weight across more wheels, giving it the power to haul brutally heavy trains over difficult terrain. The catch? Instead of one engine to maintain, crews now had two full sets of cylinders, wheels, and mechanical systems. Every flexible joint and connection needed constant attention. The locomotive was enormous, fuel-hungry, and complicated to operate, and its size made it a poor fit for routes with tight clearances. And since it was steam-powered, crews still had to handle all the backbreaking work of feeding it coal and water on top of everything else. It had the power to move mountains of freight, but getting that power onto the rails came with a mountain of complexity to match. And there you have it, 9 of the most ambitious, most infamous, and most gloriously flawed trains ever built. From jet-powered railcars to nuclear missile launchers disguised as commuter trains, engineers have never been short on wild ideas. The problem is usually turning wild idea into something that actually works every day. If you enjoyed this, make sure you're subscribed so you don't miss the next one, and drop a like before you go. It really does make a difference. Thanks for watching, and I'll see you in the next video.